Here's a summary on what to do when you're asked to find a limit analytically. So the first thing you want to do is direct substitution. And if you actually get a legitimate answer, that's going to be the limit. So that's very easy. So if we're looking at the first one, we have the limit as x approaches 2 of 5. Now remember, 5 is the function. It's a very simple function. Sometimes you forget what that actually means. Well, if this is the x and the y-axis, the graph of y equals 5, and it is y equals 5, it is exactly what it says. It's y equals 5. So this limit, as x approaches 2 of 5, 2 can be anywhere, is always just 5. That's a property of limits, so you don't have to look at the graph. The limit of a constant is always a constant. The next question, limit as x approaches 1 of this composite function, very complicated function. First thing you do is direct substitution. Plug 1 in. So we have the square root of 3 minus 4, negative 1, plus 3, which is 2, over 1 cubed plus 1 is 2. Square root of 2 over 2, done. Don't have to do anything else. And this is the beauty about analytical limits. If I were to ask you to do this numerically or graphically, there would be no way you would get root 2 over 2 because it's an irrational number. You would never come up on that exact answer. Here we did. This exact limit is root 2 over 2. That's a great answer. The next one. The limit as x approaches 2 of this complex fraction. Remember, it's a complex fraction if it has fractions in either the numerator or the denominator. So the first thing we're going to do, as always, is direct substitution. When you plug in 2, you get 1/4 minus 1/4 over 2 minus 32, which is 0 over negative 30. Don't be afraid to get 0 in a numerator. 0 divided by any number is just 0. So this limit is 0. So that's analytical limits are very, very, very easy if you get answers. When they become difficult is when you get when you have a problem. That sounds stupid, but I'll show you. Last example I wanted to show you is example number 4, limit as x approaches 7 of 3x plus 2 over 2x minus 14. That's a 14. Looks horrible, sorry. So when you plug 7 into this one, it's 3 times 7 is 21, plus 2 is 23. Over 2 times 7 is 14, minus 14 is 0. That's the problem. You can't divide by 0. 23 divided by 0 is undivided. Now, as far as the limit goes, you have to go back to, there's 2 reasons why limits tend not to exist. One reason is a vertical asymptote. And remember, a vertical asymptote happens at values of x that the denominator goes to 0, but the numerator does not. That's what this is. So we can say right now this does not exist. The limit does not exist because of a vertical asymptote. So the only time you're going to have to do any work is when direct substitution doesn't work. That is when you are left with 0 over 0 when you use direct substitution. So the next videos will show you an example, actually 3 examples of that. So stay tuned.